What do you think the ground we walk on every day is made of?
What makes up the ground? Soil?
That's right. The very thing that makes up the ground is soil. But do you know that the soil has different characteristics? Look at the soil on your shoes.
It's dark brown and has a slightly distinct smell.
Exactly. Different types of soil have different characteristics. Let's do an experiment related to soil. Let's prepare and follow the experiment steps.
First, put soil in a test tube and add water to the soil at a ratio of about 1:5. And mix the contents of the tube well, then wait for at least 30 seconds.
After some time has passed, insert the universal indicator paper into the test tube and measure the pH concentration. Next, add a few drops of vinegar to the soil. Mix well, then perform the same experiment as before. All right, how's the pH of the soil?
It's hard to distinguish colors, but it seems to be close to neutral.
Is that so? Then, how about the soil that had vinegar mixed in?
It seems to lean towards the acidic side, I think.
Is that so? Because the vinegar was absorbed into it, the soil turned acidic. This is related to the soil pollutants. When the soil becomes acidic, plants don't grow well, leading to desertification.
Do such things really happen?
Yes. Pesticides, chemicals, oil, and garbage can change the characteristics of the soil, ultimately affecting the ecosystem.
Wow, I'd like to know more specifically.
All right, let's use textbooks and activity materials to study pollutants, sources, and effects of soil pollution. Let's go! Will water and oil mix? You will know if you've ever done the dishes. Oil doesn't wash away with water. Let's find out if they actually mix. Let's prepare and follow the experiment steps. First, pour about 1/4 of water into the beaker. Then, fill the remaining 1/3 of the beaker with oil. Now, observe if they mix. Next, add the effervescent vitamin tablet and observe. All right, did the cooking of oil and water mix?
No, they separated into layers with the cooking oil on top and the water at the bottom.
Exactly. Since oil and water have different densities, they don't mix with each other. The water, being denser than the cooking oil, sinks to the bottom, while the cooking oil floats on top.
Ah, that's why when we added the effervescent vitamin, the water foam it created didn't mix with the cooking oil, but settled down again.
So, what would happen if oil leaked into a river or ocean?
I guess the oil would float on top of the water.
Smart guess. When oil leaks into the river or oceans, it doesn't mix with the water and floats on the surface, leading to severe water pollution.
I think I've seen this scene on the TV news.
Right. So, shall we find out how pollution affects aquatic ecosystems?
Oh, let's do it. Let's learn more about water pollution.
All right. Let's use textbooks, activity materials to study pollutants, sources, and effects of water pollution. Let's go! How much discomfort or annoyance do we feel at different noise levels? Let's find out through an experiment. Let's prepare and follow the experiment steps. First, make various sizes of sounds directed towards a person. Measure the level of discomfort inducing sounds using a decibel meter. Then, measure the decibel levels of 3 or more different sounds, at least 3 times each, and calculate the average value. Oh, my ears! How do you feel after measuring various sizes of sounds?
Thoughts.
Right? Usually, sounds above 65 decibels are classified as noise, and such noise-induced environmental pollution is called noise pollution. Let's continue to explore the substances or causes of noise pollution and their effects, shall we?
Sounds good. Let's learn more about noise pollution.
All right, let's use textbooks and activity materials to study pollutants, sources, and effects of noise pollution. Let's go!